This is video 2 on our series on how to make a coil and a coil's life. So this is where my coil will actually fit. It just screws onto the fitting. Very, very simple. If I turn that on, you can see how it rotates, and that'll be for our spinning later. Now what we're going to be doing here is we're going to be making the chase that's going to straighten out our magnetic wire prior to spooling. I've found that that's very important to not take it directly off of a spool onto your coil, and the reason why is because you'll get back springing on your coil, and you really want to straighten out that wire before it actually engages onto your spool. So how we're going to do that is we're going to take a couple of bits of wood and a couple of drill bits, and we're going to take 3 pieces of plastic. Doesn't matter really what type of plastic, but I'm just using this. This is ABS, just standard utility plastic, not a great big thing. Now what I will do when I set these, I'm going to separate these out just slightly so you can see it, is I'm going to offset them about 1/2 of an inch. So the reason for that is when I drill the holes and then I align them back up when I'm making the device here, that will cause our wire to actually angle as it goes through here, and I'll show you that as we get more into it. So we have our 2 braces here, and how that's going to work is we're going to attach one piece here, we're going to attach the next piece, then we will attach our other brace here, and then we will attach our 3rd piece of plastic here. And once we drill the holes through the plastic and then we feed our magnetic wire through, you'll see how that angle straightens out our wire. So our next step here, as you can see, we've got our magnetic wire ran through here. I usually set this wall array about 8 inches away from the center of our coil, and I've found that that's a good rating to have so that you can manipulate that wire. And a lot of times because of that distance it'll track itself, so after the first couple of windings you can really let it go by itself, and it seems to track okay. Now if you look at the wire here, I'm not sure if you can see this very well, but you can see how crooked and kinked and everything it is here. It passes through the first wall, and then it comes up and it comes through the second wall, and then it comes back through the third wall, and then it goes to our spool. And what that does is that back creases the wire so that it's extremely straight after that. So what do we have here? We have our magnetic wire. You can kind of see if I show you how that actually works. If I pull the wire, you can see how it straightens it out at this end. If I kink this up quite a bit and make this really kinky so that you can see that it's really kinky, and once I take this and I pull it back through here, you'll notice that all of those kinks are now gone. And that's the main thing. If you have some wire that's really kinked up, you can of course increase this to 3, 4, 5 times. Basically all I did was I used a screw on one side to hold it together and a screw on the other side, and those screws go all the way through the unit. And then I took and drilled 2 holes in each end, and I countersunk those, and that will be for how I'm going to actually screw it down to our actual platform. A couple of things. An extension bit for your drill is imperative to get down into those tight places where your drill won't fit. The other thing is, on countersinking, you can use a standard size bit that's the same size as the top of the head of your drill. The only thing that you have to remember on that is to operate the drill bit backwards. That way it doesn't chew through your material, it just countersinks or alls out the top. So run it in backwards. That works for wood or plastic, even metals. So that's a good tip for you there. On the holes that I drilled through, it's always the center of the shaft of the screw, so that the threads will actually turn in, but you cut down on the resistance, especially going through really thin material. That'll help you to stop from breaking out. On our next size down bit, that was actually for, and I'm not sure if you can see them, they're right here. I have a larger hole and then a really small hole next to it. And remember, I offset these and then I drilled the hole straight through so that everything will line back up. You want your first row and your last row to be identical straight across, and that way it'll straighten the wire correctly. If they're off a little bit, sometimes it won't straighten the wire. So that's that part. Now, a little tip for you as well. This drill bit here is too fine to actually fit inside of my drill. So the actual drill itself, the actual tip here, is too big to accept this drill bit. So if I show you that, it just goes in and out even though the drill's all the way closed. So what I did was I wrapped some electrical tape around the drill bit, which is a perfect way to increase the shank size without increasing the drill bit size. And so you do that, and then what I do is I leave a flag on it, so if you can see that, so that the drill bit can be recovered. And then all you do is you just peel the tape back off. Now the drill bit, because the electrical tape is soft, it will find the center of the drill bit, so it actually operates just the same as if it was just the shank. And it's sticky enough that it works really well. Just tighten it down and it'll find the center, and then you can drill straight through. And that's how I use smaller drill bits in my larger drill if the shank is too big. You have to adjust this if you have wider spools. You always want this X port of where the wire comes out to be in the center of your spool. So left, right, and center. And I'm going to go ahead and install this, get that screwed in, and then okay, and there you can see that it's attached, 2 screws, and it's attached quite firm. Okay, let me show you how to feed your wire. There we go. You can see your wire going through, and then all I do is I kind of feed it over and let it find that hole, and then I just use my finger to push it through. So you can see how it comes through on that side. And then what I'll do is I'll grab it and I'll pull it up, and keep in mind that I've left these so that they're pretty flexible. And then what I'll do is I'll feed it back through our larger hole here. And that's pretty much it. And that's how it fits. So you can see how the wire comes through the side, comes over, back, and out. Okay, so I feed our wire through our spool, and I'm just going to hang on to this end. We're just going to turn that on, and it's going to find itself there, and then all we're going to do is just feed and wrap, just like this. And as you can see, even without having the spool on the other side, we can wrap an extremely nice tight wound coil here. We're going at a correct speed so that we can actually use our fingers and get this coil just as perfect as you can. And keep in mind we're only using 1 wire here, but this is going to be the same purpose for both wires, and so we can go ahead and get this spooled up really, really nice. You'll notice that there's some tension there. Because of that tension, you don't have to worry about your coil backspooling. As you can see, I'm not hanging on to it or anything. That's a beautiful thing. So as you can see on our coil, it's extremely consistent and tight. And that's the main purpose of why I built this coil winder the way that I did. Is it's very slow, it's very controllable, and your coils will come out perfect every time. Alright, and I've got to build the section next, which is going to be how we're going to hold our spools up, and then we'll go ahead and spool up a real coil, which I've shown how to build the wire straightener and tensioner for spooling your wire, and how the motor operates to spool the wire onto your coil. That concludes video 2, and I will be back with you with video 3, and that's everything for right now. Thank you very much.